Welcome to your Introduction to Statistics Lesson 2-3. Today we're going to summarize sets of data with percentiles of 5 number summaries. Okay, so what is a percentile? For any whole number p between 1 and 99, the pth percentile of a distribution is a value such that p% of the data fall at or below it. So if you're in the 98th percentile, that means that 98% of observations fall below whatever your value is. So if you're in the 98th percentile for height, for let's say we'll go back to young men, ages 18 to 25, that means that 98% of young men fall at or below that value. The percentage falling at or above the pth value would be 100 minus p%. All right, so here we've got the 60th percentile and of a particular distribution. It's biology test scores. So the 60th percentile is 79.5. So 60% of the scores are at or below, and 40% of the scores are at or above. And it may seem weird that the at is here on both of them, but that's because it's a continuous distribution, and so you would be able to have the at for both cases. If it's a discrete distribution, then the percentile is just the percent below. And then the 100% minus p% would be at or above. Okay, so we've got different percentiles here. So your lowest percentile, the lowest score is going to be at like the first, second, third percentile, and the highest is going to be at the 98th, 99th, and so forth percentile. So one of the main things we're interested in are quartiles. Those are percentiles that divide the data into fourths. Now, don't try to make a direct analogy between statistical quartiles and then the quartiles of classes of where students fall in their class at Houston Christian, because the analogy does not work at all. Okay, so just kind of keep them in separate places in your mind. For instance, the first quartile in statistics is the bottom 25% of observations. Okay, the first quartile is the 25th percentile, so it marks off the lowest 25% of observations. Well, at Houston Christian, the first quartile are people with really high grades. It marks off the highest observations, the highest grade point averages. So please don't try to make this concept of quartiles match with what you know of as quartiles as far as class rank and that sort of thing goes. So Q1 marks off the 25th percentile. So 25% of observations are at or below that. If it's continuous, if it's discrete, it's 25% or below. Q2 is the median, marking off 50%, and Q3 is the 75th percentile, marking off 75%. So here you go. You've got your minimum. The first 25% of observations fall between the lowest and the first quartile. The next 25% fall between Q1 and the median, which would be Q2, but it already has a cool name, so we just call it the median. And the median is the 50th percentile. Another 25% to give you the 75th percentile for Q3, and then we go up to the maximum. So computing quartiles, you want to order the data from smallest to largest, and you're going to find the median, the second quartile. So you're going to divide it in two, find the middle value. Then you're going to take the first half and find the median of the data falling below Q2. Okay, the median of the overall distribution is Q2. So you're going to find the median of the first half of the data, and that's going to be Q1, and then you're going to find the median of the second half of the data, and that's going to be Q3. So one thing that we do to measure variation whenever we're working with quartiles and median, because median and quartiles go together just like mean and standard deviation go together, a way to measure the amount of variability is through the interquartile range. And so that's Q3 minus Q1. So a lot of times you'll look at the range when you're working with median and then the interquartile range, because that gives you the spread of the middle 50% of the data. Okay, so let's look at this in actual practice. So we're going to find the quartiles of this set of data. They happen to be ordered, and so you can just count in to the middle value, and the middle value is 24. So here's our median right here. It's 24. All right, so we've underlined it so we can see where it is. So now, and that's technically Q2. That's our median. Median and Q2 are the same thing, but we just typically call it median and not Q2. All right, so now we're going to look at the data below this, and we're going to find the middle value of that data. Okay. So for the data below the median is 17. So for all of the data that are not pink here, we count in. So let's see, 1, 2, 3, 4. The fifth value in from the lower end is 17, and 1, 2, 3, 4, 5. The fifth value in from the upper end is 17 for that half of the data. So that's Q1. That's our first quartile. Now we're going to do the same thing with the upper end. So everything here, everything bigger than 24, everything bigger than the median. So we're going to count in 1, 2, 3, 4, 5. The fifth value is 33, counting from the max. 1, 2, 3, 4, 5. The fifth value counting in is 33, and so the third quartile is 33. Okay, we want to find the interquartile range, so we just do Q3 minus Q1. So that's 33 minus 17, and so you get 16. So there's 16 units of spread in the middle 50% of the data. All right, a good way to summarize the data is by giving something called the 5-number summary. So you're going to give the lowest value, the minimum, the first quartile, the median, the third quartile, and then the highest value, the maximum. And a graphical display of the 5-number summary of data is called the Box-and-Whisker plot. One var stats is another way to find those values of the minimum, maximum, first quartile, median, and third quartile, or you can always find them by hand like we talked about just immediately prior to this. The Box-and-Whisker plot, if it's oriented vertically, you're going to have your lowest value at the bottom, the highest value at the top, and the box itself is going to go from first quartile to third quartile. You're going to show the median in the middle, and then you're going to have whiskers that extend down to the lowest value and up to the highest value. If it's horizontal, then the lowest will be to the left and the highest will be to the right, just like normal. Values tend to get higher as you move from left to right. All right, so making a vertical Box-and-Whisker plot by hand, you're going to draw a vertical scale, including the lowest and highest values. So here we would have, if our lowest value there was 1, we might go, and the highest value was, I don't know, let's say it's 24. We would go perhaps from 0 to 30 on our vertical scale. To the right of the scale, draw a box from Q1 to Q3. So if you look, there's a box going from Q1 to Q3. See how it's a nice little box there? To the right of the scale. Draw a solid line through the box at the median. So let's look at what that looks like. You have a little horizontal line here right at the median, showing where the median is. And then you're going to draw lines, the whiskers, from Q1 to the lowest and from Q3 to the highest values. So here's our whisker going from Q1 to the minimum or lowest value, and our whisker going from Q3 to the maximum, the highest value. Okay, so we're going to construct a vertical Box-and-Whisker plot by hand. The lowest or minimum is 12, the Q1 is 17, median is 24, Q3 is 33, and then the highest value is 51. We found Q1, the median, and Q3 previously. Because this is an ordered list, it's very easy to find the lowest and highest values. All right, so we need to make sure that our lowest value on our scale is less than 12 and the highest value is larger than 51, so going from 10 to 60 is certainly sufficient. We're going to draw the box going from Q1 to Q3, so we need to approximate where 17 is and draw a little horizontal line segment there, and then go up and draw another horizontal line segment at Q3 and then finish on our box. Then we want to draw in our median at 24, so we approximate where 24 is, and we draw another little horizontal line segment. Okay, we come back down to Q1 and we drop a little vertical whisker down to 12. our lowest value, and then we come back up here to 33 and where Q3 is, and we extend a vertical whisker up to 51 where our maximum value is. Now, you can also construct a box and whisker plot on the graphing calculator. It is by default going to give you one that's horizontal, which is great. You can do horizontal or vertical. It doesn't matter to me. You're going to enter the data in a named list in a document. You can just call the list values, just give it a name. Then you're going, and remember that needs to be done in a list and spreadsheet page. So go ahead and do that. Open a new document and then insert a list and spreadsheet page. Name column A, something like values, and then enter the data. Go ahead and pause the video and then come back and we'll talk about what you need to do from there. Okay, welcome back. Add a data and statistics page. Remember, you want to do that by pressing the dock key and then inserting the data and statistics page, just like you did when you were going to make a histogram. All right, choose the name you gave the list as the horizontal variable. All right, and then choose menu, because we're not adding a page, we're doing something with the information on this page. So you go to menu, select plot type, and then box plot. And boom, there you go. You've got a horizontal box plot. And go ahead and draw that on your notes. Okay, outliers. Outliers are data values that are so high or so low that they seem to stand apart from the rest of the data. They lie outside the general pattern, which gives them the name outliers. Where do they come from? Why are there strange values? Well, sometimes they're data collection errors. All right, if you are recording, let's go back to our example, heights of young men age 18 to 25 in inches, and someone records accidentally in centimeters, then that's an error, and you're going to get this huge number that doesn't really fit the overall pattern. It could be a data entry error. You could accidentally add a 0 at the end. You can do 2 data values in one cell. Those happen all the time, so you need to go back and look at that. Number 3 could be valid but unusual data values. Okay, if we had a guy who was 6'10", he's going to have a value that is probably going to be an outlier compared to the rest of the heights that we get in our data set. It's just we've got a really tall guy, so sometimes those things happen. Outliers must be identified to determine whether they are the result of an error or if they are a valid but unusual value. One way to test for outliers involves using the IQR and the first quartile and third quartile to establish limits for data values. Sometimes these are called fences. You'll hear me say what's the upper fence, what's the lower fence. You can also use the term like your book does, lower limit and upper limit. Any data values falling outside these limits are considered outliers. So that's why I like kind of calling them fences, because anything that lies outside the fence is an outlier. Limits works well too. The lower limit or lower fence is going to be Q1 minus 1.5 times the IQR. So we give a little bit more spread than what's found in the IQR. We do 1.5 times that IQR, and we subtract that from the first quartile. And then the upper limit or upper fence is going to be the third quartile plus 1.5 times the IQR. So let's look at our data set there and see if we have any outliers. Our first quartile is 17, our third quartile is 33, our interquartile range again is 33 minus 17, so it's 16. 1.5 times our IQR, 1.5 times 16 is 24. So we're going to look at 24 units lower than the first quartile and 24 units above the third quartile. So our lower limit or lower fence is going to be 17 minus 24, which is negative 7. Well, we don't have any negative values up here, so we certainly have nothing smaller than negative 7, so we don't have any low outliers. We can already tell that. Our upper limit is going to be our third quartile plus 1.5 times our IQR, so 33 plus 24, so 57. And we don't have any observations above 57, so we don't have any large outliers. So values that are not outliers fall in the range negative 7 to 57, including the endpoints. Well, all of our values fall within that range. Okay, everything from 12 to 51 is between negative 7 and positive 57. So we have no outliers. But let's play what if. What if we had a data value of 60? Well, 60 does not fall between -7 and 57. Okay, 60 is greater than 67, so it would be an outlier. Likewise, if we had a value of -10, -10 is less than -7, so we would have an outlier in the small direction. If we had a data value of 60, we would want to see if it was the result of an error or if it was just an unusual but valid value. You can't just throw it out because it's an outlier. You have to look at it and think about whether it's the result of an error. So if it's the result of an error, you want to fix the error and then look at the data set. If it is a valid but unusual value, you have to include it. One thing you can do if you feel like it really is something exceptional and it's going to be misleading in how to handle whatever observations you're looking at. If you were buying, I don't know, school uniforms for a bunch of kids and all of a sudden you had this guy that was 6'10", and you're like, well, the chances are in the future we're not going to have another person who's 6'10". What you can do is you can look at your distribution with the outlier in it and then look at your distribution without the outlier in it and then make proposals on what to do as far as buying bulk school uniforms, whether you want to include a uniform that would fit someone who's 6'10", or if you wouldn't, and just special order if a student like that happened to arrive at this school. Okay, that is it for your 2-3 notes. Please do the problems to try on your own and come to class ready to go over it. Thank you for taking great notes, and I hope you have a wonderful day. I look forward to seeing you in class. Bye-bye.